In this video, we are going to see about what is Z-test in hypothesis testing. What is Z-test? A Z-test is a statistical test used to determine whether two population means are different when the variances are known and the sample size is large. It is a form of hypothesis test that is used to decide whether to accept a null hypothesis or not. As a statistical test, it is univariate, and the test statistic result is expected to follow a standard normal distribution. It is employed only when there are a known standard deviation and a large sample size, n greater than 30. What are z-scores? Z-scores or z-statistics are numbers that represent how much the test statistic results have deviated above or below the mean distribution. For example, a z-score of plus 1.45 signifies that the test statistic result is 1.45 standard deviations above the mean. In contrast, a z-score of minus 1.45 implies that the observation has deviated 1.45 below the mean population. Z-test calculation. The following formula can be employed to compute a z-test. Z-test equals x bar minus mu, divided by sigma, divided by square root on n, where x equals sample mean, mu equals population mean, sigma equals standard deviation of population, n equals number of observation. Types of z-test. There are mainly two types of z-test. 1. One-sample z-test. 2. Two-sample z-test. One-sample z-test. We perform the one-sample z-test when we want to compare a sample mean with the population mean. Here's an example to understand a one-sample z-test. Research question. Let's say we need to determine if girls on average score higher than 600 in the exam. We have the information that the standard deviation for girls' scores is 100. So, we collect the data of 20 girls by using random samples and record their marks. Finally, we also set our value, significance level, to be 0.05. Solution. In this example, mean score for girls is 641. The size of the sample is 20. The population mean is 600. Standard deviation for population is 100. Since the p-value is less than 0.05, we can reject the null hypothesis and conclude based on our result that girls on average scored higher than 600. Two-sample z-test. We perform a two-sample z-test when we want to compare the mean of two samples. Here's an example to understand a two-sample z-test. Research question. Here, let's say we want to know if girls on average score 10 marks more than the boys. We have the information that the standard deviation for girls' score is 100 and for boys' score is 90. Then we collect the data of 20 girls and 20 boys by using random samples and record their marks. Finally, we also set our value, significance level, to be 0.05. In this example, mean score for girls, sample mean, is 641. Mean score for boys, sample mean, is 613.3. Standard deviation for the population of girls is 100. Standard deviation for the population of boys is 90. Sample size is 20 for both girls and boys. Difference between mean of population is 10. Thus, we can conclude based on the p-value that we fail to reject the null hypothesis. We don't have enough evidence to conclude that girls on average score of 10 marks more than the boys. Pretty simple, right? When should a z-test be conducted? The following conditions should prevail to perform a z-test. 1. The sample size must be more than 30. 2. The sample data should always be random. Otherwise, the test statistic results may turn out to be inaccurate. 3. The data points must not be similar. Besides that, they must not overlap with each other. 4. The data must reflect a standard normal distribution. 5. The standard deviation of the population has to be known. 6. If the population standard deviation is unknown, it should be assumed that the sample variance is equal to the population variance. Note: however, in case the distribution variation is not known, and the sample data is below 30, a t-test will prove to be more suitable than a z-test. How to conduct a z-test? The following steps should be followed to conduct a z-test. 1. First of all, the null, h0, and the alternative hypothesis, ha, needs to be stated. 2. Now, select the alpha level. 3. The z-table has to be employed to define the criticality of z. 4. Now, the z-state statistic has to be calculated. 5. Once the test statistic result is obtained, compare it with the critical value z. 6. The comparison will lead you to the conclusion if the null hypotheses, h0, can be accepted or not. Understanding logic of hypothesis testing, with the graphical representation for normal distribution. Typically, we set the significance level at 10%, 5%, or 1%. If our test score lies in the acceptance zone, we fail to reject the null hypothesis. If our test score lies in the critical zone, we reject the null hypothesis, and accept the alternate hypothesis. Critical value is the cutoff value between acceptance zone and rejection zone. We compare our test score to the critical value, and if the test score is greater than the critical value, that means our test score lies in the rejection zone, and we reject the null hypothesis. On the opposite side, if the test score is less than the critical value, that means the test score lies in the acceptance zone, and we fail to reject the null hypothesis. But why do we need p-value, when we can reject, accept hypotheses based on test scores, and critical value? P-value has the benefit that we only need one value to make a decision about the hypothesis. We don't need to compute two different values, like critical value and test scores. Another benefit of using p-value is that we can test at any desired level of significance by comparing this directly with the significance level. This way we don't need to compute test scores and critical value for each significance level. We can get the p-value and directly compare it with the significance level. Examples of z-test. Example 1. Research question. A school claimed that the students study that is more intelligent than the average school. On calculating the IQ scores of 50 students, the average turns out to be 11. The mean of the population IQ is 100, and the standard deviation is 15. State whether the claim of principle is right or not at a 5% significance level. Solution. First, we define the null hypothesis and the alternate hypothesis. Our null hypothesis will be HO, mu equals 100, and our alternate hypothesis HA, mu greater than 100. State the level of significance. Here, our level of significance given in this question equals 0.05. If not given, then we take alpha equals 0.05. Now, we look up to the z-table. For the value of equals 0.05, the z-score for the right-tailed test is 1.645. Now, we perform the z-test on the problem. Z-test equals x bar minus mu, divided by sigma, divided by square root on n. Where x equals 110. Mean, mu, equals 100. Standard deviation, sigma, equals 15. Significance level, alpha, equals 0.05. N equals 50. Z equals 110 minus 100, divided by 15 divided by square root of 50, equals 10 divided by 2.12 equals 4.71. Here 4.71 greater than 1.645, so we reject the null hypothesis. If z-test statistics is less than z-score, then we will not reject the null hypothesis. Example 2. Research question. Suppose that, in a particular geographic region, the mean and standard deviation of scores on a reading test are 100 points and 12 points, respectively. Our interest is in the scores of 55 students in a particular school who received a mean score of 96. We can ask whether this mean score is significantly lower than the regional mean, that is, are the students in this school comparable to a simple random sample of 55 students from the region as a whole, or are their scores surprisingly low? Solution. First, calculate the standard error of the mean. SE equals sigma divided by square root of n equals 12 divided by square root of 55 equals 12 divided by 7.42 equals 1.62, where sigma is the population standard deviation. Next, calculate the z-score, which is the distance from the sample mean to the population mean in units of the standard error. Z equals m minus mu divided by SE equals 96 minus 0 100 divided by 1.62 equals minus 2.47. In this example, we treat the population mean and variance as known, which would be appropriate if all students in the region were tested. When population parameters are unknown, a student's t-test should be conducted instead. The classroom mean score is 96, which is minus 2.47 standard error units from the population mean of 100. Looking up the z-score in a table of the standard normal distribution cumulative probability, we find that the probability of observing a standard normal value below minus 2.47 is approximately 0.5 minus 0.4932 equals 0.0068. This is the one-sided p-value for the null hypothesis that the 55 students are comparable to a simple random sample from the population of all test takers. The two-sided p-value is approximately 0.014, twice the one-sided p-value. Another way of stating things is that, with probability 1 minus 0.014 equals 0.986, a simple random sample of 55 students would have a mean test score within 4 units of the population mean. We could also say that, with 98.6% confidence, we reject the null hypothesis that the 55 test takers are comparable to a simple random sample from the population of test takers. The z-test tells us that the 55 students of interest have an unusually low mean test score, compared to most simple random samples of similar size from the population of test takers. A deficiency of this analysis is that it does not consider whether the effect size of 4 points is meaningful. If instead of a classroom, we considered a subregion containing 900 students, whose mean score was 99, nearly the same z-score and p-value would be observed. This shows that if the sample size is large enough, very small differences from the null value can be highly statistically significant. See statistical hypothesis testing for further discussion of this issue. Advantages of z-test. The following are some significant advantages of the z-test. 1. It is a straightforward and reliable test. 2. A z-score can be used for a comparison of raw scores obtained from different tests. 3. While comparing a set of raw scores, the z-score considers both the average value and the variability of those scores. Disadvantages of z-test. Despite its various advantages, the z-test suffers from some significant limitations. 1. Z-test requires a known standard deviation, which is not always possible. 2. It cannot be conducted with a smaller sample size, less than 30.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.